Hey everybody, today we are talking about molarity. You should have already had a basic intro, but we'll recap here quickly. The specific concentration of a solute within a solvent is going to be called our molarity. So the molarity refers to the concentration of a given solution, which again is made up of a solute, what is typically being dissolved, and a solvent, which is typically what is doing the dissolving. And the overall concentration of that solute is called molarity. So the higher the molarity, the higher the concentration. So what does it mean? It just means how much solute is in a given amount of solvent in our solution. So how concentrated that solution is. How is it calculated and why does it matter? Well, let's look right here. We explored with this PhET just a little bit. If you didn't get a chance to explore with this PhET, I would encourage you to look at this. It'll give you more of a visual idea of molarity and how molarity works. Now, how molarity is calculated. Molarity is calculated by doing the moles of solute over the liters of solution. I also gave you a little conversion chart here. 1,000 milliliters equals 1 liter. So to discover the molarity of a solution, first of all, let's establish a few things. Molarity is represented by a capital M. So anytime you see a capital M, that is talking about molarity. Liters is a capital L, and moles, of course, is M-O-L-S, just like that. So this is really just a simple equation. If you set it up, you have molarity equals, and then it's going to be moles. I should just type this. This writing just takes forever. Moles over liters. So that is going to be the solution that you always use. You will always be given two numbers in every molarity problem. So the first thing that you need to do every single time is identify the numbers you have been given. So let's look at this first one. You're given 18 moles of sugar and 27 liters of solution. Now you look here, moles fits in here on the top, liters fits in on the bottom. So you're going to be solving for molarity. This right here, highlighting green, this is going to be your unknown. So from there, you just plug in to solve for the molarity. So we are given 18 moles of sugar. So we would do 18 on the top over 27 liters of solution. Now it's key. It always has to be in liters. So if you're given milliliters or something else, you're going to have to convert. So 18 over 27. So we get out our nice calculators. We do 18 divided by 27, and we get 0.67. It's round to two significant figures. So 0.67 is our molarity. So that would be our final answer for this question, would be a molarity of 0.67 if we were given 18 moles of sugar in 27 liters of solution. It would be a 0.67 molarity. Now the higher the molarity, the more concentrated the solution. So if we were working with hydrochloric acid and we had 12 molar hydrochloric acid, that's very dangerous, very concentrated hydrochloric acid. If we had 1 molar hydrochloric acid, still dangerous, not quite as serious. So the higher this number, the more concentrated it is. So let's look at our second one. First thing we do, identify the numbers we are given. We are given 1.4 moles and 4.2 liters. Look back at our original equation. Moles will go on top. So we have 1.4 moles on top, and that will go over 4.2 liters. So because we've been given those two numbers, that means we are solving for the unknown, capital M, molarity. So all you do then, 1.4 moles divided by 4.2 liters, you're going to end up with a molarity of 0.33. So your solution has a molarity of 0.33. So that is going to be our molarity for our second one. You always identify your two numbers and then just go from there. On to number 3. This one is going to be a little bit different. First, we're trying to figure out the molarity, how concentrated something is. But what we're given the molarity here, we're going to have to change up our process a little bit. So we circle our two numbers that we have been given, and we look at what they are. We're given 0.500 liters, so we know liters based on our equation. I'll rewrite our equation right here just so you can see it. You have molarity equals moles. Man, moles take so long to write with this pen. I got to get better at this. Moles over liters. So our first thing we've been given is liters. So we'll go ahead and write liters on the bottom. We've been given 0.500 liters. That's what we have on bottom of our equation. I'm just filling this in based on the numbers I've been given. Now we've been given a capital M. That's molarity. So we've actually been given the molarity. So our molarity here, we've actually been given, so we have to put that in the right spot, which is right here, 2.0. See how I'm matching this to the equation? 2.0, 0.5, right there. Our unknown is going to be moles. We don't know how many moles of solute we're using. So that's what we don't know. And if we look at the question, that's actually what it asks, how many moles of solute are involved. So all you have is 2.0 equals moles over 0.500. Easiest way to do this is to just go ahead and cross multiply. So you do 2.0 multiplied by 0.5, and you end up with 1. So you end up, your final answer is going to be 1 mole of solute. And you just did that by cross multiplying. Just basic algebra. All you got to do is cross multiply one time. You end up with 1 mole of solute being used in that situation. Now our last one here. This one's a little bit of a tricky question. Let's identify our numbers first. Let's identify the first one in this awesome color right here. We've been given 2,000 milliliters. That's our first one. And then we've been given 3.5 molar. We can go ahead and write that down. 3.5 molar. Because we know that's going to go on this side, right? That's where I'm getting that. 3.5 molar equals, and then we have to have moles over liters. But we haven't been given moles or liters, but we've been given milliliters. So you have to convert milliliters into liters. So that is why I gave you this fancy conversion chart. There are 1,000 milliliters in 1 liter. So to solve for how many liters this is, you just need to do 2,000 milliliters divided by 1,000. 2,000 milliliters is the equivalent of 2 liters. So anytime you are given milliliters, which you will be on occasion, you have to convert it to liters before you can finish the problem. So we're given, let's draw our division line right here. We've been given 3.5 molar, and we've been given 2 liters. I got that 2 liters by converting 2,000 milliliters to liters based on this conversion right here. And then we do not know how many moles we have. So again, that's what we're searching for. So we do not know how many moles we have. So again, just like the previous problem, we're going to cross multiply and solve for moles. So you do 3.5 multiplied by 2, you get 7. So this equals 7 moles. Now, you'll notice here the question is asking for grams. And I didn't tell you what the solute is. The only way you could solve this is if you knew what the solute was. So we're going to go with the solute as being, we'll just say we put in calcium. So calcium has a molar mass of about 40 grams. So that would mean we have to convert this into grams. And the reason I'm doing this is because it says how many grams of solute are involved. And we decided, because I didn't put what type of solute we were using, we're going to say we were putting calcium in there. So I would just convert moles into grams. 1 mole of calcium, 1 mole of calcium equals 40 grams. Just our basic conversion from our earlier unit on dimensional analysis. So you do 7 times 40. You would end up with 280 grams as your final answer. 280 grams. So that question was a little bit different because it asked us, we were given, man, that is a terrible 280. We were given milliliters and we were given molar, and then we ended up solving for moles, which is correct. But then it was asking for grams, so we just converted the number of moles of calcium that we solved for into grams of calcium. So that is a basic synopsis of molarity. You're going to have some time to practice it. If you need help, as always, just ask. Okay. Farewell. Good luck.